Hi students, welcome to another video of Smartly Learn. In this video, we are going to solve the first question in exercise 1.2. The question is, prove that root 5 is irrational. Before we start to prove that, first let us try to decide the approach on how to go about this. In maths, there are many approaches to solve a problem. One such approach is called proof by contradiction. So what do I mean by proof by contradiction? I need to prove that root 5 is irrational in this case. So where I will start is, I'll assume a contradictory statement to what I need to prove and then say I'm not able to say this as true. And so whatever I had to prove comes true. So let's see how to approach it. I need to prove root 5 is irrational. So I'm going to assume that root 5 is rational. So this is what the assumption is going to be. So from here, my attempt is going to be to disprove this particular statement, that is root 5 is rational. So the moment I disprove this statement, I can claim that root 5 is irrational. So with this assumption, let us understand a little bit about what are rational numbers. So a rational number can be always expressed in the format a by b. Any number or rational number can be expressed as a by b on the condition a and b are co-primes. So what do I mean? I cannot in literal terms simplify a and b by using any common factors. So the next step in proving or disproving this assumption is that I have to find out a factor that is common to a and b when I claim this to be a rational number. So let's see. So if I say root 5 is rational, that means root 5 can also be expressed as a by b. So this means a is equal to b root 5. Now let's square on both sides. So this tells me a squared is equal to 5b squared. Now, this also means that a squared by 5 is equal to b squared. Therefore, 5 should definitely have been a factor of a squared. So, let's say this means 5 is a factor of a. Now, the next step that I have to look forward is to prove that 5 is also a factor for b. So once I say a common factor here, then I can disprove the claim that a and b are co-primes. Therefore, I can go back to the statement root 5 is not rational. So let's find out how to find if b has also 5 as a factor. So now I said that a is divisible by 5. I can write a by 5 as some constant c, which means a is equal to 5c and a squared is equal to 25c squared. So here I already know a square is 5b squared. I just found out a squared is also 25c squared. So from this equation 1 and 2, I can say that 5b squared is equal to 25c squared, which means c squared is equal to 5b squared by 25. So c squared is equal to b squared by 5, which tells me that 5 is a factor of b, because I'm able to divide b square by 5 to get a whole number c square. We already know that 5 is a factor of a, and now we know that 5 is a factor of b. Therefore, a and b are not turning to be co-primes, correct? So a and b are not co-primes. This means that the assumption that we said that root 5 is rational is wrong. Therefore, root 5 is not rational because the assumption itself goes wrong. Therefore, root 5 is irrational. Because our assumption is wrong, I am able to prove the original statement that root 5 is rational. In the next video, we will see how to solve the second question in this exercise. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.